Good morning, everyone. Today's webcast is being recorded and will be posted on the ELOSC website. I would like to welcome everyone to the winter webcast of the Eastern Lake Ontario Northeast Swallow-wort Collaborative, also known as ELOSC. My name is Robert Smith. I am the Terrestrial Restoration and Resiliency Coordinator for the SLELO PRISM and the Nature Conservancy in New York, and I'll be your facilitator on today's webcast. I would like to ask participants to mute your audio to reduce feedback during today's webcast. Our webcast this afternoon is designed to continue our discussion on managing swallow-wort, one of the Northeast's more aggressive invasive species. We will be hearing from Audrey Bowe of the New York Invasive Species Research Institute and our guest presenter, Dr. Andrea Davalos from SUNY Cortland. There will be an opportunity for questions after the presentation. The Eastern Lake Ontario Swallow-wort Collaborative is a platform for sharing the most up-to-date research and best management practices to inform stakeholders about the prevention and management of this highly aggressive invasive species. We hope the ELOSC will foster greater cooperation and collaboration between different stakeholder groups to improve control and spread prevention focused solely on swallow-wort. Additionally, this collaborative helps to transfer knowledge between researchers and managers, share advances in science and management, provide technical assistance, and connect the stakeholder community. Our tagline for this collaborative is linking people, information, and action through enhanced communication. Current collaborators include Cornell Cooperative Extension, the Nature Conservancy, the New York Invasive Species Research Institute, the University of Rhode Island, New York State Department of Parks, Recreation, and Historic Preservation, Wells College, and the Thousand Islands Land Trust. Any stakeholder organization that embraces this effort is invited to become a collaborator. It is quite informal, no papers to sign, just a willingness to share information. Please contact me at robert.l.smith@tnc.org or any one of our collaborators should you desire to collaborate. Next, I would like to introduce Audrey Bowe, who is the Assistant Director of the New York State Invasive Species Research Institute. Audrey has some information and updates that she would like to share with us. Audrey?
Great, thank you so much for the introduction, Robert. Can everybody hear me okay?
Yes.
Great, thank you so much. Okay, yes, so I just want to share a brief update about the work of the Swallow-wort Biocontrol Research Group in New York State. This group is funded by the Department of Transportation and includes Dylan Terry from SUNY ESF, Jackie Schnurr from Wells College, Lindsay Milbrath at Cornell, and our speaker today, Dr. Davalos from SUNY Cortland, as well as staff at the New York Invasive Species Research Institute. There's some good news on the Hypena opulenta rearing front. Hypena opulenta is the approved biocontrol for swallow-wort. However, as you may be aware, availability of this agent for release has been a limiting factor in the advancement of the program. So in the US and Canada, many of the colonies that are rearing this agent have been infected with a pathogen known as microsporidia, which was killing a large proportion of the larvae before they could reach adulthood and leading to overall low colony numbers and low number of agents available for release. However, this past fall, Dylan Terry at SUNY ESF has been experimenting with artificial diet and different rearing conditions, and he's been able to, in his colony, decrease larval mortality from around 95% to about 12%. And so we're hopeful that this means there should be plenty of agents for release in summer 2020 into the research plots. The group is also currently in the process of planning for summer fieldwork, including some summer swallow-wort and vegetation monitoring and germination studies. And finally, the group is also taking steps to establish a standardized monitoring protocol across research groups and develop versions of these monitoring protocols, which can be used by managers as well as researchers. Thank you so much.
All right, thank you, Audrey, for the update. I would now like to introduce Dr. Andrea Davalos. Andrea is an assistant professor in the Biological Sciences Department at SUNY Cortland. She is also part of the team of collaborators assembled by Carrie Brown Lima, director of Cornell University's New York Invasive Species Research Institute, that works independently on different aspects of swallow-wort ecology. Please share your questions in the chat box and we will get to them after the presentation. Andrea, the floor is yours.
Okay, good morning, everybody. Can you hear me okay?
Yes.
Okay. Thank you, Rob, for inviting me today to give this presentation and for everybody for tuning in. I'll be talking a little bit about a project that we've been doing together with New York State Parks to look at how they are managing pale swallow-wort and how can we gauge the effects of other agents of change such as deer, invasive earthworms, and invasive plants. So just as a little bit of context, although I'm preaching to the choir, we all know that invasive plant species are considered a major threat worldwide. They have a myriad of effects, from reducing native vegetation to changes in ecosystem properties as nutrient and water availability, and that they are very pervasive in New York State. So we have lots of problems, lots of very different species there depicted on the pictures. So not surprisingly, we put a lot of time and effort in prevention and management of invasive species. We have invested a lot of money. For example, the budget for the US, for federal budget for in management of non-invasive species has risen to more than $2 billion in 2016. So there's a lot of time and effort put into this. And on top of that, we do spray a lot of hectares of public lands to control for invasive species. So we would expect that all of these effort that we're putting together is actually leading us to really positive results. However, there are areas where we've done, despite the efforts, we've done very little progress. We can still not predict which species are going to become invasive, and we still need to further reduce the number of new introductions. So for example, the map there on the right was put together a few years ago, showing the number of insect pests that are per county in the US. You can see that New York is quite purple, so the higher number of invasive insect pests per county. Of course, we have a huge port of entry, so we still need to be working on reducing those new introductions. At the same time, we have very limited evidence of the negative impacts of invasive species and invasive plants. We assume that because an invasive plant has become really abundant, it has negative impacts, but sometimes when we look for that quantitative evidence, it's just not there. And in many occasions, we found that some invasive species are drivers, not passengers of change. So they are the symptom, not the cause. And as can you imagine, that's going to have effects on how we decide to manage the invasive species. Because if we are managing for restoring native vegetation, for example, but that native vegetation is damaged there, not by the invasive species, but by other factor, we should be tackling that other factor, not the invasive species necessarily. And on top of that, the assessment, sometimes we go out there, very often we go out there, we sample, we manage for the invasive species, but we fail to monitor afterwards and actually learn from what we're doing and determine whether our actions were really successful or not. Except for very few cases where we have very good documentation. This is an example from the Adirondacks, the pictures on the right, the Phragmites management done by the TNC. And this is an excellent example of very long-term monitoring that actually has helped us identify what is working in the program and what could be improved. So with that said, it seems that it's very important for us to have a different approach, an approach that's based on adaptive management. And this is not a new idea. It's just an idea of managing in a way that we can learn from it. So at the top on the circle here, we have a problem, in this case, an invasive species. We design an action, for example, maybe go out and applying a herbicide, we implement it, and then we monitor, evaluate, and adjust as needed. So in this circle of learning, we can adjust and we can learn from what we're doing, but we can also take into consideration uncertainty, things that we cannot plan for or things that we don't know just yet. But one thing that might be lacking from this adaptive management is the idea that there needs to be collaboration between partners, between researchers and management. Rob started his presentation by saying, well, we want to transfer information. I would go a step further and say that we really want to bridge that gap between research and practice, and we want to co-produce information. But bridging that gap is sometimes difficult because we, as managers and researchers, we might have very different objectives. So sometimes scientific knowledge might be insufficient in extent. We might have, as researchers, not generated enough data to actually resolve the problem, or that data might be difficult to access because it might be behind a paywall or might be difficult to understand. And sometimes the data that we generate is not easily translated into practice. So there's that scientific data that cannot be used for management. And at the same time, management often does not have an explicit goal of gaining the knowledge. So there's no monitoring and assessment involved into the practices, and therefore we have very limited learning as to what's working and what's not working. And we rely a lot still on managers' expertise, and that is not necessarily something that can be replicable across sites. So if we have an approach where we think about co-producing knowledge, we will still have this cycle of learning where we first plan and set objectives to then have an action that's implemented and then evaluate those actions, reflect. So were we successful and how can we improve? And then based on that, reformat our objectives. Usually, and very commonly, managers are involved just in the planning and implementation. So we're losing an opportunity to actually co-produce the rest of the knowledge and be involved throughout the process and learn through it. So under that realization, that is how we started this project together with New York State Parks and the New York Invasive Species Research Institute. So we thought, what if we build a partnership where we have researchers, as myself, representing there from SUNY Cortland, and we have managers as New York Parks and Recreation, where, as you know, manage a lot of land in the state and do manage for invasive species, and we have extensive methodology and extensive investment in invasive species management. And then the New York Invasive Species Research Institute served as this liaison between the two parties, helping us find an appropriate framework to work from and setting common objectives. So we wanted to really build up from this startup and ask these questions from our work together. And these are really like big questions that we're not going to answer in one project. But those are our goals behind this partnership. Can we quantify impacts of invasive species in a better way? Can we define success of when we go out and manage for pale swallow-wort? Can we define what the success is? And can we measure those success, those management actions in a way that's effective, that's easy to measure, and that we can be using for learning in the future? So, as you see, these questions are really big questions, so we needed to narrow down, and that's where swallow-wort came in. Pale swallow-wort was at the moment one of the biggest and largest threats within parks, so we decided to focus on that particular plant species. So as part of this collaborative, this would seem very redundant. We know that pale swallow-wort is spread through the Northeast, and it becomes very abundant. It's a perennial twining vine, so it's a long-leaf vine, and it twines around itself and other plant species. And as it does that, it can have impacts on other native vegetation as well as in agriculture. For example, Christmas tree growers see it as a problem because it affects the way the tree is growing. But there's also competition with other plant species. There in the middle, it's hard-tongued fern, federally listed species that occupies same locations as pale swallowwort is occupying. So there's an encroachment of habitat. It's in the same family as the milkweed and produces similar chemicals. So sometimes monarch butterflies make a mistake and lay eggs on pale swallowwort. However, the monarch butterfly larvae cannot complete its development. At parks, it was quite extended in many of the parks in Finger Lakes region and Central region where we are working, and was identified as one of the major threats. So it was one of the major targets for control where people were going out regularly to manage for it. And the management was a mixed approach. When the populations were really small, not as the one that's depicted on the picture, they will go out and dig up in the individual plants. But you know that these plants, when they're long-lived, they have like big crowns, and it's really difficult to control a large population by digging. So then they will try to do seed head clippings, and this was just basically with the idea that they will reduce seed bank, and over time the population will decrease. And when we started the project, they didn't really have any more tools at their disposal. Right now, they're working with herbicide applications through several grants, especially trichoflare, specifically for swallowwort. So that opened up new possibilities of managing larger populations. And as Audrey said, a lot of the biocontrol program that we've started has some research sites within New York State parks. So hopefully in the coming summer and years, we will be implementing a biological control program. So all of these mixed management approaches were being done, but there was very little data that was going to be collected from swallowwort. So when we started thinking about how to assess whether the impact of swallowwort and its management was effective, we had this recognition that biotic stressors do not act alone. So by biotic stressor, I mean an agent of change that can threaten biodiversity that might not necessarily be pale swallowwort. Other thing on top of that. These stressors are widespread and co-occur, so they happen at the same location at the same time. And when they are acting together, they might interact in a way that they can be positive and reinforcing relationships, or they can also ameliorate the impacts of each other. So those things are really important to be able to consider if we want to think about what's the impact of pale swallowwort. So we use an approach that we call a multiple stressor approach, one that's moving towards a more realistic ecological scenario. A recognition that pale swallowwort does not occur in a vacuum, and it's not the only organism that's causing change at a given habitat. And we selected two other stressors. These stressors are white-tailed deer on the left and invasive earthworms, plus pale swallowwort. So as a little bit of background, white-tailed deer is an abundant native species. All of you probably have seen that beautiful tree line that they do as they eat everything that's across their height. But despite being generalists, they do have some preferred species. So those species that are preferred usually get limited recruitment and their abundance goes down, or they are not able to reach reproductive status. And at the same time, some non-palatable plant species get at that benefit because they're not eaten, and at the same time, they are released from competition from native plant species. So it's like a double gain for those. And many of those non-palatable plant species are invasive species. Swallowwort being an example. Deer would not eat pale swallowwort, and therefore, but it will eat everything around them. So is pale swallowwort benefiting from that effect of deer herbivory? Deer also, those impacts on plant species usually ricochet or move into different trophic levels and affect ecosystem processes. And these can be very long lasting. So if you can see the picture there on the bottom that depicts the fence, that's a fence that prevents deer from getting into the plot to the left, and you can see the amount of vegetation. The comparison of vegetation is quite striking between the two of them. But it can take a very long time for those changes to happen. And also, some species might not be in the seed bank anymore, so they might not be able to come through. Now, earthworms, most of the earthworms that we see in New York State, especially in our forests, are not going to be native. They're going to be introduced from Europe or Asia. And we usually have a combination of 5 to 16 co-occurring species of earthworms. The pictures there, the two top pictures show red wigglers and night crawlers. And these are species from European origin. As far as we know, that's the current hypothesis. And these are used for fishing baits, so you might be more familiar with them. They have been spread throughout the state for a longer time. On the other hand, the one at the bottom, here the one I'm showing with my cursor, that's a jumping worm. Jumping worms are been in the state for more than 100 years, but their spread has been pretty recent. So they are moving northwards and becoming much more widespread. And they have generated a lot of concern among managers and the horticulture businesses and industry, and they are on our forests. So we wanted to see what they were doing. So earthworms are ecosystem engineers. They can alter the physical and chemical properties of the soil. So they change the soil to their own benefit, kind of in the similar way as beavers do, and they do a pond around themselves. Earthworms change the soil to their own benefit. And as they do that, they change the bulk density and the aggregation of the soil, which as a result means that the soil will be more compacted and water will flow in a different way. So water, instead of percolating down slowly, will run off, causing more soil erosion. At the same time, there's going to be a change in the concentration and availability of nutrients. Nutrients might be moved into the mineral soil or might be flowing at a different rate. Ultimately, we can see that effect. On the picture on the left, you see a soil that does not have earthworms, where you can see very clear soil profiles. You can see a rich organic matter, and then followed by the mineral soil. Whereas on the right, you don't have leaf litter, very little organic matter, and the mineral soil is way on top. So you can imagine that these will have impact on plants and how plants are doing. And it is true, we are changing the soil from fungal to bacterial dominated. So a lot of the mycorrhizal associations might be disrupted and more bacteria will be there. And also we will increase drought sensitivity. So as the soil gets compacted and there's no leaf litter and there's no isolation and no buffer, sometimes roots get exposed, and as they get exposed, they might dry out, and seedlings are particularly vulnerable to that stage. It's also being showed a lot on species that have roots that are quite superficial, as in sugar maple. So it's been shown that sugar maple roots are very superficial. The leaf litter goes away, the soil gets compacted, roots get exposed, and there's a big dieback of sugar maple seedlings. And on top of that, earthworms, we think about them as detrivores, so eating things that have been, that are dead already, but sometimes they can be herbivores, although it's not a huge part of their diet. But on the picture on the bottom that marked as B, you can see how they're eating green material. So they can have direct effects on plants. And these will then change plant communities in a way that we can determine locations where earthworms are really abundant and whereas locations where not as abundant. Some of the species that are going to be really winners and are going to benefit from having earthworms there might be grasses and sedges, especially because they're not mycorrhizal species. Whereas the species that don't do as well when earthworms are present might be longleaf perennials like trilliums and some plants that are very common in our understory, and also woody seedlings. And there's been lots of work that have shown that earthworms are associated, have this positive association with invasive species, especially buckthorn, steelgrass, and garlic mustard. So we know that where these plant species are present, earthworm populations are really high, and vice versa. We don't know who is causing the benefit or if they're just selecting the same location that's good for both of them, but we do know that there's that positive association. For buckthorn, though, there have been some studies that shown that the buckthorn leaf litter is really nutritious and that earthworms like to actually use it. So given all of these stressors that were happening together, we wanted to ask this question: how are these three agents of change related to each other? So is deer benefiting swallow-wort, or are earthworms associated with swallow-wort, for example? And we set up not knowing those answers, but with some hypotheses. And to answer those questions, we set the following designs. So we selected two areas, one that where swallow-wort was being removed, so where it's targeted for management, and one where swallow-wort was not removed, so where it was not targeted for management. And as I said, we are working together with parks as a partnership, and I think this was the first hurdle we found on how to do management in a way that is effective and at the same time have a suitable reference site that we can learn from. Because if we don't have a reference site, there's very limited amount of information we can gain. And that was the first difficulty we had. But after finding that, we defined these two areas, one where there was management and one where there was not management. At each one of those areas, we set up 3 plots. One, the deer were excluded, so that's the minus deer here, so where we build up a fence, so deer will not be able to go in. And then a parallel open plot where deer are able to come in. And both areas had swallow-wort. Now, very close to that area, we also had a third plot where there was no swallow-wort. So it was very close to where management of swallow-wort was happening, but in that particular area, swallow-wort had not arrived. So we guarantee that communities and other conditions of the site will be much more similar. And the same thing was done in the not removed sites. We did this at 3 sites in New York State Parks, Buttermilk Falls and Tulane Falls in the Finger Lakes region, and at Green Lakes State Park up in Syracuse. And that's the crew putting up together some of the fences that were built up in 2017. The first question we asked was managing really reducing swallow-wort? And I'm going to present cover data here, but we also have data on density of swallow-wort. And you can see on the figure, we're showing swallow-wort cover on the y-axis, and then on the x-axis, we have the data divided by the area where swallow-wort was removed to the left in red, and the area in the right where swallow-wort was not removed in blue, and the 3 years where we have data for. The management started in 2017 at these locations, and you can see that the mean percent of pale swallow-wort cover, which was around 30% in 2017, reduced significantly after just 1 year of management to 2018, reaching less than around 5% cover. And then in 2019, pale swallow-wort cover was less than 1%. So we're really getting, reducing that abundance, significantly reducing that abundance. At the same time, where swallow-wort was not managed here on the right, the blue dots, you can see that there's no difference among the years, and that swallow-wort cover is pretty stable, telling us that the difference that we're seeing are really a result of the management we're doing. So that's encouraging. We are managing and actually reducing swallow-wort cover, making it not the most dominant species at our sites. So now let's think about how swallow-wort is related to the earthworms. As a setting up for hypothesis, we know that earthworms change these competitive relationships between native and non-natives, and that we have some documented positive associations between invasive plants and earthworms. So we are expecting a positive impact. So we will expect a positive association between earthworms and swallow-wort. So how to test for that? We sample earthworms in each one of these plots. To sample earthworms, you would use mustard, a mustard solution. Mustard is a skin irritant. So as we pour it on the soil, as you can see one of the students doing it there on the right, the earthworms don't feel comfortable, emerge to the topsoil, and we collect them, preserve them for future identification. This is not a control method, this is a sampling method. And from there we can estimate the abundance, the number of species of earthworms we have, as well as the biomass. So looking at this relationship, we started with a hypothesis of positive relationship, and the graph here shows earthworm biomass on the y-axis and pale swallow-wort cover on the x-axis. For 2 years of data, 2019 data has not been processed yet. So the black dots and the black line represent 2017, and you see some positive relationship. As swallow-wort cover increased, so did the earthworm biomass. However, in 2018, we don't see that relationship. The relationship is completely flat, and you will also notice that earthworm biomass was really small. 2018 was a little bit of a weird year. We had times where it got really warm and then really dry and then rainy again, but then really dry again. And I think the worms did not respond well to that. So the earthworm populations really collapsed. So we don't know if this lack of relationship in the second year is because the populations of earthworms were really small, or it might also be because we had also manipulated pale swallow-wort cover already by applying herbicide. So as that pale swallow-wort cover decrease, those relationships with earthworm biomass will be disrupted too. So we are looking into different ways of approaching this question. But so far, we can say that there's no really a relationship between swallow-wort and earthworms. So, okay, we did not find that relationship between swallow-wort and earthworms, but our swallow-wort, how is it related to native vegetation? And we expected a negative impact because it's encroaching in its habitat. And we also expected a negative impact of earthworms on native vegetation because we know from previous research that that's the way it usually goes. So we assessed this at each one of those plots again by doing a vegetation community analysis. So we went out to each one of these plots and put in permanent quadrats that we're going to revisit over time. And a student in the lab, an undergraduate in the lab, took it as an independent project, and he went out and monitored each one of these plots and determined the cover and density of pale swallow-wort, as well as the cover of each one of the vascular plant species that was present there. And then we looked at that data. So we found in this understory vegetation around 83 plant species, 59 of them native. So you can right away see that, yes, swallow-wort was a really important player in our system, but there's many other invasive species too. So by taking care of swallow-wort, we're not necessarily taking care of the whole problem. Multiflora rose, buckthorn, garlic mustard, and barberry were pretty common at the sites. But we did find some species that are associated with our understories and some rich communities, especially at some of the sites. Some of the other sites were much more depopulated. So when we looked at, we wanted to make sure that our management was not affecting the species richness. So the data here is showing the species, the native species richness between areas where swallow-wort was removed on the left and areas where swallow-wort was not removed on the right. For 3 plots, the fence plot in green, the open plot where deer had access in yellow, and the plot with no swallow-wort in light blue. We're not looking really at differences between fence and open because this was done in 2017, the same year that we put on the fences together. So we really cannot look at an effect of deer. But you can see that within the same area, there's really no difference in the number of species where swallow-wort was removed versus where it was not removed, and between the areas that were treated and the areas that were not treated for swallow-wort. So that is encouraging. We're not affecting other species with our herbicide application. But there's another thing that's showing up in this graph, which you can see that overall, in these areas that swallow-wort was not removed, we had a higher number of species, of native species, indicating that the areas that were targeted for management were not necessarily the areas that had the highest diversity of understory. There might be areas that for other reasons they were picked up for management, but not necessarily because they're withholding the highest diversity. So when we looked at vegetation composition, so how are these communities assembled? And this graph is just showing the associations between the plant communities. Points that are closer together in the graph are indicating more similar plant communities. Each one of the dots is a quadrant. And the first thing I want you to take out from this is that there's very clear, very different communities according to site. The 3 sites that we worked at had very different communities, each one of them represented by an elliptic there of a different color. And you can see that there's a little bit of overlap, but they're really having very different populations. And that signal of site-to-site variation ended up being much more important than the signal of having or not having pale swallow-wort in determining the communities and the plant species that were present. So here's a similar graph to the one I just presented to you, looking at this multivariate analysis, but now the points are not colored according to which site they belong to, but they are colored according to whether swallow-wort was present or not. So swallow-wort cover, actually, from 0 to 60%. So lighter points will mean highest abundance of swallow-wort. And you can see that the vegetation is really not grouping itself together according to whether there's a lot of swallow-wort or very little swallow-wort. Really, the points are spread out almost as a random. So we are not finding that communities of swallow-wort, communities with swallow-wort are very different than the communities that do not have swallow-wort. We did find, however, that the communities of plant species were highly dependent on whether earthworms were there, especially jumping worms on the plot on the right. So you can see on the plot on the right, there are a bunch of points or several points that are light blue. Those are points that have higher biomass of jumping worms, and those are separating itself from the other plant communities. Interestingly, these plant communities were very rich in poison ivy. So I think it would be a really interesting follow-up experiment to look at how these jumping worms and poison ivy are interacting with each other. Seems like a great combination in a place I don't want to be, lots of poison ivy and lots of worms. So back to our hypothesis. So no impacts on swallow-wort and the earthworms. We did not find any difference between swallow-wort and the native vegetation at the community level in this snapshot of what we did. But we did find a negative impact of earthworms and native plants. So very different plant communities depending on earthworms were there or not. So now we added the third part, which are deer, and looking at whether deer had negative impacts on native understory, and whether that those impacts of deer will be related to the presence and absence of the native of the introduced plant. And to do this, we did a little bit of a different approach. We used plant sentinels. So plant sentinels are indicator species that we grew in a common garden or in a greenhouse and then transplanted into our field sites. And this method has the advantage that it's not dependent on the current vegetation. So as you just saw the plant communities that we had at each one of our locations was very different depending on the site. So the fact that we can compare the same species across multiple sites makes it easier to generalize our conclusions. So it's easy to replicate across sites, and it also allows us to evaluate restoration. As we take swallow-wort out and there's some other invasive species, and the seed bank might not hold a lot of other species, we need to think about what are we going to plant and how are we going to restore these forests. And these might give us some information on whether these species can actually grow there and can do well. So we selected 4 species that are common in forests in this area, and we transplanted them. So the point here in the middle was marking our planting location. To the left at 9 o'clock, there's a woodland aster, and to the right at 3 o'clock, there will be a solid flexicollis. So that's zigzag goldenrod. And at 12 o'clock on the top, a Christmas fern that was just transplanted this year. And I have to say thank you to Audrey for providing me all of those wonderful plants. And then at 6 o'clock, a white ash that was also transplanted in 2017. So we transplanted these seedlings in 2017, and we are currently following them to see how well they survive and how much they're growing. So I'm going to show you a little bit of preliminary data on that. The figure here is showing the proportion of seedlings that survive according to each one of the species. So the picture on the right depicts the species that we're talking about. And on the left, the two left bars are where pale swallow-wort was removed. The two right side bars are where pale swallow-wort was not removed. The plots, the seedlings that were transplanted into fence plots where deer were not accessible are in black, whereas the open plots are gray. And overall, you can see that survival varied according to species. So for example, the solidago did really, really well. We got a survival or almost 100%, whereas the revia only survived around 40%, which was a little bit different. Now, notice that there's so far no difference between open and fence in survival. These seedlings were quite small and below what a deer can eat. So if there had been any effect, it would have been a non-consumptive effect, and we did not find any evidence of that. But we expect these differences to increase as these seedlings increase in height and then are vulnerable to being eaten by deer. Similarly, when we looked at size, again, the plot looks very similar to the one you just looked. We just went over. For here, I'm showing just 3 species, and we're looking at the size overall and comparing them across plots. And again, we don't see a big difference between fence and open, except for one location for woodland aster, which seems to be doing much better at locations where swallow-wort was not removed in the open plot. And I don't know, we cannot tell why this is happening and if this is quite true or it was just a fluke of that year and what was able to survive. So I'm really interested in pursuing this question over a few more years and seeing how those woodland aster do over time and what happens as they start growing and become available for deer feed. So far, as we expected, the impacts of deer would be really small because these seedlings are still very small and below the size where they can be eaten. But nevertheless, I think that the way that we're learning from this system is challenging some assumptions. Non-native plants many times are just a symptom rather than the cause. So we find these locations where deer are eating everything with very little understory. Swallow-wort is just occupying this beautiful empty space. We also find that a site-by-site variation, so land use history and specific conditions of each site might be a stronger predictor of what's going on than actually non-native plant impacts, especially on swallow-wort. We find these legacy impacts of white-tailed deer where we have the depopulated seed banks. But we do know that the herbicide is being efficient at taking care of pale swallow-wort, but we also know that its application might be limited in time and space. It's not something you want to be doing at the same locations over multiple years because we know that eventually we're going to have a detrimental impact on native vegetation. So we do are looking forward to implement different methods like biological control that will not require these chemical outputs. So overall, we want to rethink species management approach, and I'm hoping that we will move from just removal, recognize that just removing invasive plants is not sufficient to conserve native plants. We really need other approaches. We need to reduce their impacts, at least where we are, and they will have a double benefit by reducing invasive plant abundance, as well as benefit native plant populations that are eaten by deer. And we really want to incorporate restoration programs into our management. Just by removing the plant species, we're not bringing that diversity that we're looking for. And ultimately, as we move forward, I'm hoping that we move from that invasive plant removal approach to a more integrated management of driving forces, which is not only work for plant removal or for a particular plant species, but we work actually for a more holistic perspective of how to manage a site. And that we as managers and researchers put much more effort into monitoring and assessment. And I would love for us to build up more partnerships between research and management. I think these are just great ways of generating valuable data. They foster learning, they improve the effectiveness of our actions, and they can be really, really productive. So I really put out a word out there to look to for your local manager and your local scientists and work together. And I think that can make us really achieve our goals of managing invasive species in a much better way. So with that, I would like to thank you all for attending, and I would like to thank my students at Cortland and with the Forces program that have worked so many hours in this project collecting data. The people at the Forces program in New York State Parks that have worked with me in the field, open up their sites, and actually help me co-produce this information, as well as New York Invasive Species Research Institute, Carrie Brown Lima and Audrey Bowe, who have provided a lot of framework and resources for the project, and the Research Foundation at SUNY Cortland, who provided initial funding to start the project. So with that, I would like to answer any questions. And thank you for listening. Hello?
Hey, thank you, Andrea, for sharing this information with our participants. Now I'd like to take some time to read questions from the chat box and take some audio questions as well.
Sounds good.
All right, feel free to ask any questions. Don't be shy. All right, what do we got? Here's a question. How do we remediate soils changed by earthworms?
Oh, that's an excellent question, and I don't have a clear answer. So unfortunately, there's no method of actually managing for earthworms. We cannot get rid of earthworms once they are at a given location. The best method we have is prevention. So trying to make sure that earthworms do not get to a particular location, rather than reduce their impacts once they are there. If we ameliorate the soil by adding leaf litter, we might be putting food for the earthworms, right? So there's not really a lot of things we can do once.
Questions in the chat. Are you going to address those next? Oh, Brittany said there's.
Hello?
Yes. There's a few questions that we're dealing with trichopper. One was, has trichopper-based herbicide application also been tested on black swallow-wort? No.
Well, we don't have black swallow-wort at the sites where we're working at. And I think Tom Hughes from Parks has addressed some of those questions in the chat. Yeah, and actually, one way in which we worked together was Parks was really doing the management part. So selecting when and which herbicide to use, whereas I was more focused on how to, what is that telling us from the site itself.
All right, so the Parks were more involved in the chemical treatment portion.
Yes. And they were making the decisions on when to apply, and also when to just come in with volunteers and dig plants out, depending on their personnel and how abundant the plant was at a given location.
Okay. All right. Oh, let me see. Another one is, will monitoring continue to try and piece out annual variations like weather? Seems like it might take more time to see changes and responses from native vegetation.
Absolutely. So the first thing I want to clarify is that the vegetation sampling that we did based on vegetation monitoring was a snapshot of locations that already had swallow-wort. We don't know how that is going to change over time as we continue on with the management, and the management is really at its infancy. So we would definitely like to repeat that over a few years after we see change, and also because the fences, we are not measuring the year impact right now. So we want to do that over time. And then the seedlings, we're only in the second year of seedling growth, and we really want to be able to continue that seedling to see how it's happening. So as long as we are able to continue on the monitoring, I think long-term data is really important when you do field experiments. There's a lot of like weather conditions or situations that are beyond your control, and only the long-term data really will help you determine what's going on.
All right, I got another question. It's from Susan Robinson. What has the mortality rate been for Hypena larvae in the field in New York State over the years?
I think Lindsay Milbreath is on the call, and he will be a better person to answer that question, as he has been releasing, he has the only release of Hypena in the state so far.
Okay, yeah, Lindsay, if you could address that in the chat, that would be awesome.
At the sites where we're working together in the biocontrol program, where Dylan Perry is raising this Hypena, we have not released Hypena so far. So what Audrey was relating to Hypena dying was in the lab during the rearing process. It was not in the field. We have not released at any of the locations, and so far we're planning to release only at research locations.
Okay.
So I have a question here that I'm reading on the chat about species richness and abundance.
Yes.
Yes, absolutely. Species richness cannot tell us the whole story about a location. So we are looking at abundance, and we're looking at diversity indexes, which put together the species richness and the abundance together. And one of the things I did not have the time to go into, but we did not find any differences when we were looking at diversity indexes. We did not find any indices, any differences when we put in invasives or non-natives also into the pool, and we did not find any differences when we looked at a specific land life forms. So we just did the analysis by sedges and grasses versus woody vegetation. We just did not find any type of indication. We are doing some preliminary analysis where we're looking at the probability of swallow-wort co-occurring with a given species. And it seems that at a very local level, swallow-wort is more likely to occur with other invasive species, like barberry especially, seems to be coming out as significant. But we just don't know whether that is translatable at the plot level just yet. But absolutely, a species richness is not the only measure and does not capture the whole reality. And that's also why we're looking at the species composition and looking at the NDNS analysis.
All right, I think that's all the time we have for questions today. Thank you once again, Dr. Davalos, for the presentation and answering some questions.
You're welcome. Thank you, everybody, for listening. And if you have any further questions, just feel free to email me.
All right, resources for the ELOSC can be found on our website at swallow-wort-collaborative.org, and Swallow-wort Collaborative is all one word. The website includes pages on control and management of swallow-wort, an upcoming events page, mapping tools, a section to post academic and practical research work, and a link with instructions on how to join our listserv. If anyone wishes to post articles of interest or publications on your work, please email them to me with permission to post, and I'll take it from there. We encourage all collaborators to take advantage of this website. Again, the site address is swallow-wort-collaborative.org. Future webcasts will occur as presenters and new Swallow-wort management information becomes available. We will make announcements about these webcasts on our website, listserv, and the SLELO PRISM Facebook page. Before I close today's webcast, are there any comments, questions, or discussions from the group? All right, if there's no,
Thank you.
do we have a comment?
No, thank you.
Oh, you're welcome. All right, if there's no more comments, that's all we have for today. I wish to thank Audrey and Andrea for taking the time to share their expertise with us today. Please check out the ELOSC website and feel free to share and invite others to participate with the collaborative so that we may continue to link people, information, and action through enhanced communication. Thank you, and have a great afternoon, everyone.
Thank you.